Hello, everybody. Hello and welcome to Altanova's Introduction to Partial Discharge Test Diagnostics on High Voltage Cables. My name is Andre, and today with us it's Lorenzo Paschini. He will be giving us the lecture on high voltage cable testing on PD. Lorenzo has been for many years in the field. He has a lot of field experience as a service engineer. He also holds trainings in TechImp. He graduated in 2013 and started working for TechImp right after that. So I think he's the best person to introduce to us this modern technology of testing. Now I give to you Lorenzo. He will also give you some advices just to give you answers to some of the questions. You will all receive the presentation afterwards from the part handouts. You will all receive the video link to what you will be seeing right now, so no need to ask for that. And if you have questions, please just ask a question and there will be one of our colleagues, Francesco, answering the questions. And later, when we finish, we can take some questions directly with Lorenzo and he will then answer them to the best of his ability. So without any further ado, Lorenzo, I give you the word.
Thank you so much, Andre. Welcome everybody to the introduction to PD test diagnostics on HV cables. As Andre mentioned, we will have Francesco Bernardi taking care of the questions. Because of the high number of participants, we cannot answer all the questions directly. So don't hesitate to make a question and Francesco will take care. In case there is not time enough to answer everybody, we'll try to reach you directly via email to answer your questions. You will find the PDF of this presentation in the handouts, and you will also receive the link to download the full webinar session. So let's start. Sorry, let's start. Okay. A brief summary of what we're going to speak about in this webinar. First, we will have a very short introduction to PD. Then we will see what are the sensor and the instrument used for PD testing on high voltage cables. We will see what are the solution of PD measurements in high voltage cable in the different part of the life of the asset. That will go into quality control at the beginning of the asset life. We will see how do we perform PD test during the HV cable commissioning. We will see also some solution for online spot test during the lifetime of the cable. We will introduce you to some interesting solution for permanent PD monitoring. And we will also see a few case studies to show you some real world advantages of PD testing. Let's start talking about partial discharge. It's always pretty easy to define PD because EAC and IEEE come to us with a very brief description that can give us a clear idea. Localized electrical discharge that only partially bridges the insulation between conductors and which can or cannot occur adjacent to a conductor. More similar to the IEEE one, localized electrical discharge that only partially bridges the insulation between conductors. So partial discharge is a localized discharge. Localized where there is a defect. The second argument I needed to introduce to you is the PD pulse, because the PD pulse will be the signal that we can acquire from partial discharge phenomena. Even here we have EAC and IEEE definition. So a current or voltage pulse that result from a partial discharge occurring within the test object under test. The pulse is measured using a suitable detector circuit, which can be introduced into the test circuit for the purpose of the test. Similar to IEEE as well, an high frequency current or voltage pulse that results from a partial discharge. In a shielded power cable, the pulse propagates away from the PD source in both directions along the cable. Here we have a PD pulse from, let's say, old school visualization with an oscilloscope. And here we have a digital visualization of the PD pulse with one of our instruments. In both cases, we have a voltage on the vertical axis and time on the horizontal axis. I cannot go too much into the detail about PD tests, about partial discharge phenomena, but I want you to be introduced to the concept of phase-resolved PD pattern. Each PD pulse is generated by a PD source, and every second we can have thousands of them. The common way to visualize this phenomena is to plot the pulse amplitude sorted by the phase angle of the applied voltage. So we will have phase angle on the horizontal axis and amplitude on the vertical axis. Why we visualize the PD pulse like that? Because the voltage is the key point to generate PD. If there is no voltage, a defector won't generate any PD pulse. And we can see by studying the phase resolved PD pattern, the characteristics and the properties of the single PD phenomena. This correlation is very important. The voltage gives us partial discharge. If we don't have voltage, we don't have partial discharge. If the voltage goes up and down as in a sine wave, we will have a pattern with some features and characteristics that we can recognize in several assets and experiences. Now let's see a small introduction about where we can have a partial discharge in high voltage cables. Here we have a cross section of a 400 kV cable. We can have a void in the XLP insulation or interface gaps between XLP and outer semiconductor layer, gaps between the XLP and the inner semiconductor layer, or we can have inclusion of external materials. So this is where we can have a partial discharge in the cable. But what happens is that thanks to the today innovation with triple extrusion, continuous improvement of the quality in the cable manufacturer production, we do not expect to have this kind of problems along the cable. Also because the cable drums, the cable reels, 400 meters about of each cable drum is tested in the factory with a very high voltage to check that is PD free. So we are expecting to find mainly PD in another crucial part of the circuit. Those are the accessories. When we talk about cable accessory, we mean cable termination and cable joints. Let's see where we can have PD in the cable termination. We can have some cracks on the outside of the insulator, so from the outside part of the termination, but as well as in the inner. We can have bubbles trapped in the insulating compound of the termination. We can have inclusion at the interface between the slip-on stress cone and the cable. And we can have as well voids or cracks in the stress cone. That is a key, that is the most stressed part of the termination. These are a few of the typical PD sources we can have in cable termination. When we go to the joints, the concept is similar, but the object under analysis is slightly different as design. We will see anyways that we can have crack and voids in the insulation body. We can have inclusion of gas at the interface between the insulation body or the cable. We can have gaps between insulation and electrode. These can be typically because of misplacement of the components of the joints or because of a pulling of the cable. And we can have as well knife cuts on the semiconductor layers during the peeling procedure when the jointers are preparing the cable for the jointing. This is a very, let's say, delicate procedures that with a very strict rules to follow to give the proper distances to the different components, and it is possible that sometimes due to some errors or cuts we can have PD as well. Now we have some pictures just to show you some, let's say, examples of what we can see in the cables with the defect. We can have internal PD in the insulation. We can have surface PD on the cable termination. In this case, here we're talking about a medium voltage, but that will give us PD signal as well. We can have a corroded shield. We can have as well broken joint. Now, what are the sensor and the instruments we're going to use for PD testing on HV cables? We will have a coupling capacitor and measuring impedance. We will have a frequency current transformer. We can have as well embedded sensor in the high voltage termination or high voltage joint. We can have external sensor for specific for some strange cases. Those are designed by Tekimp and they are flexible magnetic coupler and the UHF antenna. We can have laboratory instruments designed to be working in the laboratory as per the ESC specification. And we can have a field testing instrument. Additionally, we will see also in this chapter a few objects that we use in the permanent monitoring. Let's start with the coupling capacitor and the measuring impedances. Those capacitors are designed for laboratory use. They are very sensitive. They are the first technology used for PD signals records, and they provide both PD signal and synchronization signal, and they normally are connected together with a measuring impedance to be used with the oscilloscope-based instrument. Tekimp produce its own coupling capacitor measuring impedances and instrument, but we can also customize our accessories to match existing laboratory in order to revamp the laboratory, bringing them from old school style to the newest technology possible to make PD tests in laboratories. The second sensor we're going to see is the high frequency current transformer. We will use it, I will call it HFCT from now on. And these sensors are used especially in the field testing for high voltage cable. These sensors shall be clamped around the ground leads of the termination or of the joints where the PD pulse will flow. And we will detect it thanks to this high frequency current transformer. This sensor will give us many information about the amplitude, the shape of the pulse, and the polarity of the PD pulse. This is a real case installation in a GIS termination. If you see, there is also an arrow in the sensor because we also can get some information from the direction of the pulse. This is another installation, always in another GIS termination. And we can provide not just one size and one kind of HFCT. We have clamp HFCT, like the gray in the top left of the screen right now. We can have directly on cable. Those have a bigger hole to be clamped directly around the cable, or we also have a permanent solution with closed clamps, with closed HFCT, sorry. Those will be installed during the cable installation, and they will be permanently remaining installed with a good grade of protection, and they will be stable for all the asset lifetime. When we talk about PD on high voltage cable, there is also sometimes the case where we can get embedded sensor directly from the cable manufacturer. These are, let's say, more typical from each cable manufacturer. There are different schools. We can show mainly two schools, the capacitive embedded sensor and the inductive embedded sensor. In this case, the customer, the utility, can ask to the cable manufacturer, please provide me the cable already with the PD embedded sensor so that I can take advantage of this sensor immediately. I really like this kind of sensor because they have a very good signal to noise ratio. So the sensitivity of this sensor is very good. And another very good point is that it's a permanent installation, so we can trend the cable condition in different times, in different moments of the cable lifetime. The sensitivity will be always the same, and we can compare the data directly. Now we'll talk about some special sensor designed by Tekimp. The first one is the flexible magnetic coupler. Basically, it's very useful whenever we don't have a ground lead where we can clamp our HFCTs. We will just install this flexible magnetic coupler over the cable and detect the data. It's not as sensitive as the other one, but it's the only solution we have if there are no grounds available or embedded sensors. Another special sensor is a horn UHF antenna. It's a UHF sensor designed for GIS, but we take advantage of this sensor when we are testing HV cable GIS termination. It can be more effective to double check problems in the upper part of the termination. Let's see what is the TechImp, let's say, family for laboratories. When we are in the factory, we will be required to test our cables or our accessory joints or termination as per the EAC 6270 standard. And our instrument is compliant with the EAC standard, but also has embedded some other solution. It has embedded also an ultra-wideband detector. And there is also a solution that is taking patent to have the instrument EAC compliant, but taking the measurement in the ultra-wideband. Another fundamental of laboratory is the PD calibrator. Even in this case, the PD calibrator is compliant with the EAC standards. We have an adjustable repetition rate amplitude of the signals. And in order to make the operator life easier, the signals can be also synchronized with the room light for easy recognition of the PD pulses. Now we go for field testing instruments. The TechImp solution for field test instrument are the Aquila family. Portable ultra-wideband detectors able to separate noise from PD signals, able to be used outside for spot testing and also for short temporary monitoring. They can have up to 6 channels connected together, and they are enclosed in a wrapped box to be used outside. Another solution that we have recently developed is the Alpha. The Alpha idea is that our customer may not be interested in being a PD specialist, may not be interested in losing time analyzing the data, and the customer just want to externalize the analysis. So the Alpha is designed to provide the instruction for the testing to the operator that only needs to follow the instruction given by the instrument to install the sensor as per the existing layout of the high voltage cable. And then we'll start an automatic session of data record. These packages of PD data will be then sent to TechImp, where me or my colleagues will take care of the analysis and of the reporting. So the idea is that if we want to provide a service of PD, we don't have to be specialists of PD. We can just have a solution that put ourselves in the condition to have the very good data to be sent and analyzed by a specialist. The latest part is the permanent monitoring. The TechImp solution for permanent monitoring is called PD Hub. PD Hub is a monitoring unit that can detect up to 24 ultra-wideband channels. We have customized the boxes depending on their protection grade, power supply, and many other things. And it's like the small brain of the monitoring system. It will record the data automatically and will send the data to the central unit. Another solution that we have introduced is a temporary PD Hub. It's a plastic box. It's not a rugged ATEX box, but is equipped with the fiber optic communication and double power supply in order to be used on site for temporary monitoring. Is ideal when we have very big HV cable PD commissioning test. Our kit right now covers maximum 45 detection points, and each box is able to detect up to 6 HV accessory. and we can still expand it. So let's see what is the advantage of using partial discharge, this a little bit unknown technology. What can actually give to asset managers? What can actually give to the liability managers? We reduce the risk of failure of the asset. That's our main goal. We want to also provide a quantification risk of the risk. And we have finally a comparable index for our fleet. I have 100 cables, 50 cables, whatever. How can I know if the condition of one of the cable is better to the other, if there is someone from this fleet that needs some maintenance? The PD can tell us if there are small defects going on. The idea is always the bed tube curve. If we have a failure rate evaluation along the time, we will have three kinds of failure modes. Early infant mortality at the beginning of the life of the insulation, a constant random failure all along the life of the insulation, and a wear out failures at the end of the life of the insulation. We want to attack each one of these failure modes in a different way, depending on where we are in the cable lifetime. When we are facing infant, how can we reduce the infant mortality failure rate? By quality control and by commissioning test. Quality control is made in the factories of the cable manufacturer, of the accessory manufacturer. So we want that whatever has to be installed on site is flawless. The EAC standards are very, very strict about this point. We want to have perfect asset coming out from the factory. Once we installed the cable, we have to perform the commissioning that double checks that yes, all the components are perfect as they came out from the factory, and also what we have introduced during the installation, so the pull of the cable, the jointing activities, the termination activities, did not affect the insulation. We want to give to the utility a perfect cable, even because we will be the first ones to avoid early failure of the cable. Will be also, under a marketing point of view, very bad. So we can fight against the infant mortality in these two stages: factory type and routine test, and PD commissioning. Then, if we want to take care about the constant random failure that we can have along the lifetime of the asset, we can perform online spot test. Our asset is maybe 2 or 3 years old. We just want to have a quick screening that everything is okay. We can do it by making a partial discharge online spot test. And we can also think about install some permanent sensor that will make this online spot test even better. It is a cheap solution because it's not a big investment for the customer, and we reduce anyway some of these random failures. At the end of the cable, the best solution for the wear out problems may be the permanent monitoring. And we should also imagine that if we install the permanent monitoring at the beginning of the life of the cable, we already have a strategic asset that can cover all these moments of the cable lifetime, from the cable commissioning up to the wear out failures. In this case, we have automatic alarms, and it can be very effective to decide if our asset can last longer or needs to be repaired, and if some maintenance is required, on which part of our cable we should invest money. Let's see now what is our portfolio, our services in the cable lifetime. When we talk about manufacturing and installation, we have first the quality control. Tekim provides instruments, calibrators, sensor, and also training for the quality control. We are very strong in the commissioning test. We provide the service that is marked with a different color, in this case blue, HV cable PD commissioning service solution. I am part of the service department, and that was the biggest activity since I joined Techimp. We also provide portable PD instrument and sensor, sorry for the mistake here. If some customers are interested in making their own commissioning test, it will require a training and some experience, but this is something that we still can provide and offer. Then when we talk about the life of the cable, we speak more about operation and maintenance. So we can provide the online spot test. Even in this case, we can just provide the service. We decide how is the best way to test the cable. We provide you the procedures, you accept the procedure, and we came and make our job. We provide you the report. Otherwise, there are also portable PD instrument and alpha. Those can be bought from the customer, and those can be used directly on the asset for every time they want. One thing that I also really appreciate is to have the installation of permanent sensor in our asset. We provide kits. Those are from the sensor to the derivation box to the installation of this sensor. It is something that we always discuss with the customer, and we try to make the life of the eventual operator that should make the PD test easier and safe. The last solution is the permanent monitoring. We have an history of HV cable permanent monitoring in various parts of the world, and the system is a 24/7 automatic acquisition and alarm system. It can also include third parts that we will see later on in the dedicated slides. Now, sorry for all this information together. I hope it was clear enough. I leave the word to Andrei for the first quiz of our.
Okay, this was very informative. Thank you, Lorenzo, for this. I hope you managed to understand some of the things. I hope most of the things which Lorenzo said. So just to give some time for the knowledge to sink in, I would like to ask you a question. So our question would be, what is the biggest advantage of PD testing on a high voltage cable? Is it A, finding the cable fault, or is it B, finding small defects and preventing cable faults, or C, evaluating cable over voltage? So feel free to punch in your answer. It is not such an easy question, but I see that already 30% of the people have voted, and we have staggering 95% of accurate answers. This is very, very good. So feel free to continue voting for additional, let's say, 30 seconds, and then we'll close the voting. So up until now, 55% of the people have voted, and 93% of you have got it correct. So it is not excluded that PD can do many things, but which one do you think is the most advantageous for when you use PD? So after a minute, 60% of you have voted, and we will give 10 more seconds, and then we will close the polls. So 5, 4, 3, 2, 1, and we close the polls, and we have here 93% got it right, and the correct answer is, let's share the results. 93% got it right, and the correct answer is finding small defects and preventing cable faults. Yes, you could find a cable fault also with PD, but that was not the intention of this question. The intention was what is the biggest advantage, and 1% evaluating cable over voltage. So thank you for this interaction. Now I'm giving you back into the capable hands of Lorenzo.
Okay. I guess Andrei has left me the word. I hope there is not a permanent technical problem.
I think I hear you fine. Can you slide the slides normally? Lorenzo, can you hear me? I'm not sure I can hear you. Is your audio on?
I hope you can hear me now, because I've seen that sometimes I'm deactivating the audio.
Okay, now we can hear you loud and clear. Can you just go back to the slide before
Sure.
this, where we get that nice lab? Thank you.
Sure. Sorry, guys, for the mistake. Anyways, we start by studying section by section the lifetime of the cable solution. So the first solution we will introduce is the quality control. This takes place in factories. I've seen that there are some cable manufacturers in the list of participants, people that work for cable manufacturers, and they perform this kind of testing. They use this kind of testing. And what I've seen from my experience when visiting high voltage cable factories is that we have two main potential users. R&D, the R&D department that maybe they need to check if the material is okay, they need to validate a prototype. And then we also have the production. So we also have to provide, as per the specification, some routine test and standard test. This should be fast and easy to do. So we have two different users, R&D that want full data acquisition analytics. They want to be able to tune every single frame of the acquisition. So we can say they are expert user and they want to modify everything. And then we have another kind of utilization of the same asset that they want the instrument to be easy to use and fast. So one object and two duties. R&D, operator mode. So we have experienced operators that they want to set and tune every single parameter. Then we have operation that need a test plan mode, fast standard test. We don't want to set any parameters, no tuning, and the test sequence shall be standard and saved for all the assets. The merge of these two comes with the PD Pro. The PD Pro is the new Techim software that provides different modes of operation. We can have operator modes where everything will be managed by the user, or we can have test plan mode, a very standardized test, easy to use. The good thing is that we'll use just one instrument and we can get both these operators, and we can save the data. We can have all the data organized in the same DB of the PD Pro. So one instrument, two duties. Then a quick look at the laboratory equipment. Many of you maybe are familiar with the ESE 60270 standard for PD testing. Normally, this standard gives us an acquisition bandwidth, suggests us which measuring circuit we shall use, suggests us which sensor we shall use, and the test methods. Techim can provide the sensor, the coupling devices, and the measuring instrument for the ESE 60270. It was the beginning of the PD testing, so it's a little bit old school sometimes, but we have a huge experience and we have now a solution that includes both easy to use measuring instrument and complex and high-level user measuring instrument. That is the PD-based tool. We go ahead in the asset lifetime and we go in the commissioning test. As I told you, this is my main activity. So we will go into different solutions. I will try to explain to you what is the testing point of view for each solution, and I also would like to underline the good points and the bad points of each solution we can have. The ESE standards recommends for each new installed high voltage cable to perform at least one AC voltage test. So we will stress our cable once everything is installed before connecting the cable to the grid, before saying, okay, the cable is perfect and can run its lifetime. The solution, sorry, are two. They are both accepted by the standards. The first is an offline test where we inject at least for 60 minutes, a voltage that is higher compared to the rated voltage of the cable, from 1.1 to 1.7. In some cases, I've seen also customer bringing this level up to 2 times the rated voltage of the cable. The second solution that is accepted as well is to connect the cable to the grid. So we will have voltage on the cable, but no current for 24 hours. These tests are pass, not passed. So if we have a fault, the test is not passed. Consider that we can pass the AC voltage test even if the cable has got partial discharge. It's not, they are making 2 different jobs. The AC voltage test is a voltage injection, pass, not passed. The PD test is something to detect if, even if the cable can pass the AC voltage test, there are some small defects, those are not supposed to be there. So the PD test is becoming more popular and popular to be performed together with the AC test. So we can perform on both solutions during the offline test and during the soak test, depending on the customer requirements, the cable layout, and the solution, the best solution for the site. The PD test is normally negotiated between the utility and the contractor that is providing the cable, that is installing the cable. From our point of view, we would like to point out some of the advantages and disadvantages those exist between the offline test versus the 24-hour soak test. When we do the soak test, we have a potential problem on the grid because it's a failure. It will be some protection will open, and sometimes the utility don't like to run the risk. So under this point of view, offline is better. On the soak test, it's let's say not so nice to make a soak test because we will include all the grid noise to the measurement. If you remember, the PD are measured as a PD pulse, but you can imagine that our network may be affected by high frequency noise as well, and that can make our life a little bit harder. Instead, when we are doing offline testing, we are out of the grid, so we are not affected by such disturbances. Another thing that can be interesting is that on soak test, we are performing the test on the 3 phases together. That can be nice for the time saving, but it's not so nice if we have some dubs on the source of the PD. This can be also a problem. Maybe we are making a mistake. There is an external PD on one phase, and we detect the crosstalk on the other phase, and we cannot. I mean, you need an expert eye in this case. Then, bad thing for the offline test is that we need more people involved in the testing, because it's not just that we connect the cable to the grid, is that we will also need a crew just to take care of the voltage generator for the offline test, and that will be also a cost. But this is the key point. The most important thing from a testing point of view is that, as I told you in the beginning, the PD are due to the voltage stress. When I'm performing a soak test, I'm not exceeding the rated voltage of the cable, so the stress is just the normal stress for 24 hours. Instead, when I'm increasing the voltage at 1.1 to 1.7, the rated voltage of the cable, I will activate defects, small defects. Those maybe are not yet PDs at rated voltage, but can be, with the aging of the cable, a future failure. So this is very important. With the offline test, I can overstress the insulation and activate some partial discharge activities. On the end, for sure, the cost of the external power supply for the offline test will be much higher than the soak test. From the testing point of view, we prefer the offline test, as I explained to you. Let's see a brief explanation. This will be the soak test. 24 hours, everything, all the 3 cables will receive a voltage. There will be our injection of voltage of the rated voltage for 24 hours. We will perform the PD measurement during these 24 hours. We don't have any overvoltage applied. We cannot change the voltage. And we may miss some of the small PD because they are not yet incepted by the voltage. And we will also have noise and disturbances from the network. All three phases tested together. Second quiz now for Andrei.
So the second quiz question will relate to what you just learned from Lorenzo. We were talking about offline testing and soak tests. So the question here would be, what is the most important limitation of a soak test? Is it the voltage frequency is 50 or 60 Hertz? Or is it the fact that the noise is coming from the network? Or is it the fact that the maximum voltage one can reach is the network voltage, UN? So we have here few drawbacks of a soak test, but what do you think is the most important drawback of doing a simple soak test? So I know that Lorenzo said it because I heard it, and it is a very important thing to keep in mind when you are testing your high voltage cables. So for now, 35% of you guys have voted, and we have 57 people giving the correct answer. And we'll leave you for 15 more seconds to see what will you say. What is the biggest downside? What is the biggest limitation of a soak test? Okay, 55% of the people gave their votes, and let's close in 5, 4, 3, 2, 1, and stop. We're closing the polls. 58% gave a correct answer, and the correct answer was maximum voltage is network voltage. So because of the fact that we cannot raise the voltage above nominal value, you cannot, let's say it like this, excite the potential PDs, which would be able to be seen if you could do a standard offline test. So I'll finish with this, and now I give you Lorenzo back. Thank you.
Thank you, Andrei. So now we'll see the offline test. Offline test of a voltage cable requires for sure an high voltage generator. Normally, these generators are resonant testing systems. We may need 1, 2, 4, 6, 8 of them to energize our cable, and we need for each of them a low voltage portable generator. If you can see the picture, there are these white transformers here. There are 2 of them, and there are 2 of them over the tracks. Unfortunately, they are not easy to find. There are a few units in the world. Depending on the circuit length and voltage, may be necessary to have more than 1 of these. And we need also some operators to, let's say, control these units. I can tell you that many times some special tuning is required, and it's a big loss of time for many people involved in the construction. The important thing that we can do with the RTS is that we are not limited to the rated voltage of the cable. We can raise the voltage injected up and down. Normally, our suggested standard is to use 3 steps: 0.8 rated voltage, and 1.7 rated voltage. Why? Because if possible, we also would like to prevent failures. So we start to inject voltage at 0.8. We check that all the accessories are okay. Then we say to the RTS operator, okay, go ahead, please, and let's see at rated voltage, in order to see if some of the PD are already occurring and to save the cable from a fault and change then the accessory or cable section. Here, there is another, let's say, doubt for the offline. We can say that there are 2 solutions mainly: simultaneous test and sequential test. In simultaneous PD test, all the detection points are checked together. In the sequential, we have some crews moving along the circuit, testing the cable accessory by accessory. Obviously, for us, it's better to have the simultaneous testing because it means that we have instruments installed on every accessory, and we can control them from remote one by one, make an easy check, and we can do it during the 1 hour AC test. Give us flexibility, and we save a lot of time during the test. Let's see now some of the good points and bad points of these two kinds of testing. On the sequential test, the bad thing is that we start to test from one side of the cable at the beginning of the AC test, and then we move to the next one, then we move to the next one, then we move to the next one, until we don't have we don't have tested all the points. So basically what happens is that when we test the last joint, that joint has received 59 minutes of voltage, let's say, and we compare that reading with the one of the first joint we have tested, where the stress was just for a few minutes. So there is not an homogeneous stress on all the cable accessories. We should take that into consideration. We have also introduced that we test all the cables and then we retest the first one or two accessory tested in order to be more effective. When we are testing simultaneously, we can also move from, let's say, point to point in a very short time. We only have to change the connection to the instrument because everything is connected and we have easy way to move to the other parts. So if we have a doubt, like I see a bad signal from this joint, or is it from the next one? I need to double check. We can do it. We can do it without losing any time. The very bad thing of the simultaneous test is that the test preparation and the effort to prepare the test are bigger. We need to set up all the instruments, set up some connections, set up some power supply along the circuit, and make everything ready for the test. It will take time, effort, and money. But the test will be shorter. So all the engineer, let's say, involved in the testing will cost less. The RTS will be used for less days. So there is also an economical advantage in the simultaneous test. Another bad point is that for the sequential is that the customer needs to be strongly involved in the sequential. We may have a problem with traffic control, police to move along the cable that are sometimes placed into the city. Instead, with the simultaneous, once we have done the installation, everything will be okay for the test duration. There are no more, let's say, exceptional problems. But on the same time, the contractors have to put some effort to prepare this. And the traffic control, as I told you, will be much easier for simultaneous tests compared to sequential. For us, the best solution is the simultaneous under the diagnostic point of view, because we'll give to the testing engineer the chance to control everything at the same time without moving up and down to the circuit and without losing time moving from one place to another. So when we do the sequential testing, normally we perform it after the HVAC test. So we will have 1 hour HVAC test, and then we ask to the customer to go, okay, we go to the joint, please raise the voltage, we take the measurement, and so on, as many times as we needed to complete the cable. So the PD test shall be performed after the HVAC test. The electrical stress is limited to the shot in this case, and we need a several voltage application to be performed in case of very long circuit. On the contrary, we don't have any fiber optic required, and compared to the SOC test, considering that we have already stressed with HVAC test the cable, we should have also small PD inside. This is an idea. This is our circuit. We have 2 terminations and 8 joints. We will start with test 1 termination, then we move to the first joint, and so on, as long as we finish the cable. That may be a very, let's say, long procedures. Sometimes we also do this test with a team of 4 or 5 engineers, but every engineer needs to have a support crew, traffic control, and It's a lot of logistics to be take care about. So if we have one operator only, the number of voltage application shots will be equal to the number of accessories. If we have more operators, we will move all of them together and we will have less shots. The simultaneous, that is our preferred solution, will take advantage of the HVAC test over voltage for 1 hour. So the regulation requires 1 hour over voltage. Okay, we will perform the test only during the 1 hour HVAC test. We will require the customer to perform as well 2 steps before 0.8 and 1.0 in order to detect the eventual PD before the fault, and then we will start the HVAC test. Consider that this is mandatory, the 1 hour HVAC test. So we are saving a lot of time compared to the sequential. Once the monitoring hardware, all the hardware required for the simultaneous test is set up, we are able to test up to 4 or 5 cables per day. We will see in the case study number 2 how these numbers can be useful with very long cables. We are using the best testing condition because we have the maximum electrical stress possible, and we can test the same accessory at different stages of the HVAC test, and we can also launch some monitoring during the HVAC test to have data of all the 1 hour test. The bad thing is that we need to install PD sensor and PD hubs for each accessory. Let's see now the very same cable layout. What we need to install temporary PD hubs for all accessories. Those will be connected with sensor to the HV accessory. Then we will have fiber optic connecting all the points, and we will have one control room with 1, 2, 3, up to 6 test engineers working simultaneously on all the cable. What are the issues of the simultaneous test? Obviously, there are 2 main issues. We need the communication because we need the fiber optic solution to make all the acquisition units communicate together with the control room. Those can be embedded in the cable or external to the cable. And we need secondary power supply. Normally, it's hard to have power supply along the cable circuits in the manholes or in the pits. So the solution we have used is to use the reliable, popular, and cheap power supply. The car batteries were our best solution. We can use the car batteries with our temporary PD hubs, and depending on the battery use, we can have 6 to 10 days of stamina to work. That's very useful because we will have installation of the testing instrument. Then we can run the test for 1 week, whatever is required, and then we can remove everything. Third quiz, sorry, Andre.
Hi, thank you, Lorenzo.
Sorry.
So I was just listening. I was just listening to this, and the third question doesn't have a correct or incorrect answer or wrong answer. The third question is, what is your preference when it comes to one question? So this is the question. When it comes to PD testing, what is your personal preference? Would you like to have a shorter testing with less insulation stress, but having a higher cost, or a longer testing with a higher or bigger insulation stress, but with a lower cost? So this is basically covering the sequential and the simultaneous testing, what Lorenzo just described. So feel free to cast in your votes. I would just like to say that we are extending a little bit, probably about half an hour, this webinar than we were expecting to, because of a lot of knowledge that needs to be transferred to you guys and girls. So I hope you don't hold it against us. So until now, 43% of people have voted, and it's 57 for option A and 46 for option B. This is just for us to understand what is your need, what is your necessity. And also, I would like to remind you that when we finish with the webinar, there will be a very short survey, like 5 questions, where we will also ask you, what would you suggest for us to be the next topic of webinar? And this would be also very cool if you could fill in, because it will give us a nice feedback to understand what would you like to hear. So until now, 61% of the people have voted, and I'm closing the ballots in 5, 4, 3, 2, 1. 56% would be shorter testing, less insulation stress, higher cost, and 45 would be longer testing, higher insulation stress, lower cost. This is important for us because it also gives us an idea how to structure our offers, especially if the sum is 101%, but that's not a problem. So I'm hiding the results and I'm leaving you in the capable hands of Lorenzo. Lorenzo, please continue.
Thank you, Andrei. So after the long part of the commissioning test, I hope I didn't bore you too much, but let's say that it's the biggest part of my job, so I wanted to share whatever I could with you. We will go for the online spot test. We are now in the middle of the life of the cable. We have chance to have a screenshot, a frame of what is occurring right now in our cable. Is it okay? Is there a PD problem or not? So we will have portable instrument. We can detect partial discharge. And what are the advantages? We have the asset under the real working condition. So it's not a, let's say, a particular testing solution. It's not an offline. We are in the normal lifetime of the cable. We cannot consider also that we cannot go again for offline tests, because at this stage, we don't want to overstress the cable useless. We prefer to make it online in the aged cables. We don't need out of service. It is very fast. And there is also a bad point. We are just watching a short moment of the lifetime of the cable. So it is possible that we may lose some future PD, but it's also possible that we picked up them and we prevent from the failure. And we also have a noisy environment. Why the noisy environment can be, let's say, tough? Because it's easy to have misunderstanding with PD signals. It's easy to exchange an external surface on the termination connection with a discharge. So we need, let's say, some skills to make the analysis, some experience on that. As I was explained to you, another question is that doing online spot testing is not even so easy. We will have many different layouts that we can face, and we need to prepare the test properly. It's not a standard test. It's not also the disturbances and so on. They will be, let's say, hard to distinguish. That's why we cannot compare it with some offline testing. Those are very automatic and where the data is very easy to understand and to analyze. What are the solution Techimp offers? Or we offer the complete service. So somebody requests me or my colleagues a survey on this cable. We ask the cable specification, we ask for layouts and so on. We evaluate the chance to make the test if it is a good test. I mean, if we can be sensitive by testing that cable. We provide a test procedures. We go on site, we take the measurement, we analyze the data, and we provide the result. Another solution, cheaper, is that the customer may want to test the cable without having the service team going to the site. So they can require an alpha instrument, the one I explained in the beginning, that is slightly automatic record of the PT data. This unit will give the instruction to the user to connect the sensor to the cable, how and where connect the cable. It will check if the signal is proper or not, otherwise will give an alarm, and will basically make a data record of a few minutes with different setups. This data package will be sent back to Techimp and analyzed by our specialist. These are the two main solutions, and every time, let's say that it's always a customization for online spot test, because you can find a very different situation. Sometimes you are lucky and you can have embedded sensor of the accessories and you can measure directly from them. Other times you need to slightly change their sensor, use a special sensor to make the measurement. and it's always, let's say, a customized solution. Then the next thing I want to speak about is something I really, let's say, want to have your attention, is the installation of permanent sensor. We have chance, especially during the installation of a voltage cable, to install permanent sensor in our asset. Too many times they are seen just as a cost, but actually is an investment. The permanent sensor give to the asset manager a lot of advantages. First, the PD sensor installed in the best position ever with the most sensitive layout. So all the next spot measurements and whatever, they can take advantage of this permanent sensor and be very reliable and with a very high quality. The second thing is that normally asset managers want to correlate the data from different months, different years of the lifetime. And in this case, with the permanent sensor, is the only case where we can replicate the very same standard condition. Same sensor installed in the same place, with the same cable connection, same signal. So the correlation will be very easy to use and very reliable. It's also ideal for the alpha automatic spot testing instrument. We will just compare the data to see if there is any change along the lifetime. It's also safer for the operators. Sometimes we have to, let's say, decline some jobs because it's not safe enough to install the sensor where they should be installed. And it's important to consider that when we install this sensor at the beginning of the lifetime of the cable, we can have the best sensor in the best position, somewhere that we cannot maybe use in the future. We cannot succeed maybe in the future in the very same place. Another good point is that having permanent sensor is useful because in case we want in the future to install a temporary monitoring system, a permanent monitoring system, the worst part of the job is already done. The sensor installation is always the more the moment where the customer requires more effort in the permanent monitoring installation. If we have the permanent sensor, it will be very easy to just derivate the signals from the permanent sensor and lead these ones on the acquisition units. Obviously, the negative point is that it will cost us some money, but as I told you, I don't consider a cost but an investment. Now we'll see some few, let's say, layouts of permanent sensor. In terminations, we will have high frequency current transformer on the ground leads of the termination. Then we can send with the coaxial cable this signal to derivation boxes accessible with integrated safety for the user, where we can directly connect with our Aquila instrument or Alpha instrument and take the measurement. On the picture top right, there is a single phase link box of a high voltage termination with the embedded sensor installed on the ground lead. Then we see what we can do with the joints. Even in this case, here is even more evident. Think about a joint. Normally, after you finish the joint installation, there is no more access to the joint. There is no more access to the single core bonding cable of the joint. You only have access to the external bonding cable of the link box, maybe. So you cannot install the sensor in the best position ever, that is the one of this picture. Here you will have the current transformer installed in the most sensitive position. You will bring outside the signal in our derivation box, and from the outside will be very easy to perform the PD test. Same things can be said when we have embedded PD sensor. Embedded PD sensor cannot be used directly. We need to have some particular feature to, let's say, perform the test in a safe condition. But if we consider this solution, see from the beginning, TechImp can, let's say, support the utility or the cable manufacturer to provide a safe and very good signal outside of the cable manual, of the joint manual. Last session, permanent monitoring. So we have been through all the lifetime of the cable. We have seen what happens in the factory, what happens during the commissioning, what we can do during the lifetime of the cable, and now we will see the most comprehensive solution we can provide on a high voltage cable. Why is the most comprehensive? One thing very good that we don't see maybe at the beginning of the life of the permanent monitoring is that we have an infrastructure ready to be used to test the cable whenever we want. So we can take advantage of the permanent monitoring even during the commissioning, for example. What are the advantages we can see? The asset will be under the real working conditions. It will be a 24/7 PD assessment. We have a ready-to-use testing hardware. We have a trends evaluation along the time, and we have automatic alarms. Additionally, we can integrate the KIMP monitoring systems with other systems. In the recent past, we have been introducing a lot of other measurement together with our monitoring, and we will see this in the next slides. The bad part is that will be a bigger investment for sure. What are the components we can have in the partial discharge monitoring? We will have a sensor, acquisition unit, and detection point, and a low voltage switchboard for each detection point. Then we will have a communication made with the red lines, if you can see. And in the end, all these data, those are acquired by the sensor, sent to the acquisition unit, made digital, will be sent to a server where all the data will be analyzed and the alarms will be eventually triggered. Sorry. What can we include in the global monitoring? We can include the third-party system like distributed acoustic sensors, distributed temperature sensor, or we can include also vibration sensor, gas sensor in case of GIS terminations, position sensor, other input models, and also we have installed monitoring where we add together with our acquisition box for PD also cameras and infrared cameras. We can have also the two things, all the data import, all the HMI integration in our T-SCADA, and we can have a global system which includes not just PD, but also all the other quantities we want to take under control. Here we have a short resume. If you see on this picture, we have on the left a list of the KIMP partial discharge system. We can have third-party devices, third-party monitoring. Then we have a central unit that provides the monitoring to a web-based application that we can access 24/7, and that will include all the different monitoring systems installed. We also have a communication protocol, so PCUA, EAC 61850, Modbus, and so on, to be integrated with the customer. Obviously, those ones have been developed when year after year we have seen that different utilities require different communication protocols, and we have now a full family of communication protocols. Then I will give the word to Andrei for the third pool.
So guys, now we have one question which hopefully will not be that difficult. The question is, when we test a cable, we usually focus on A, the jacket of the cable, B, terminations and joints of the cable, or C, the conductor of the cable. So if you have been listening attentively until now, you would know which is the correct answer. And I see that already 1/3 of you has given mostly the correct answer, so we have 95% the correct answer. for now. And 50% of the people have voted. Oh, it seems that this is a little bit easier question, and that's why I have so many people voting all of a sudden. So that's good. So 60% of the people and 89% are giving the correct answer. So that's very good. By the way, I hope you like the knowledge which was given to you by Lorenzo. Now we have some examples, and I think we'll be about 20 minutes later than we were supposed to, and after that we'll have a sessions question. So until now, 63% of the people have voted, and we're closing in 5, 4, 3, 2, 1. Poll is closed, and the correct answer, which is B, termination and joins, was correctly answered by 87% of you. So thank you for that. And I give you for the last part to Lorenzo to show you some examples from his fruitful career as a service engineer.
Thank you, Andrei, and very good with the answers. I'm happy that it was quite clear what we wanted to explain. Let's see, we will have three very simple case studies. In this case study, maybe we'll see a few more of technical, like we will see a PD pattern, something more related to, let's say, a result. I mean, I didn't explain this one at the beginning. The idea for this webinar is that it's an introduction. Hopefully, we will follow with some more accurate and technical webinar. And I hope, even if we didn't introduce too much about the PD data and PD pattern, this case study can be clear for everybody. The first one is a 150 kV cable, very short, termination to termination, substation cable, basically from overhead line to GIS switchgear. So one outdoor termination and one switchgear. Tested with the RTS, so there was a chance to modify the voltage injected in the cable. We have installed our HFCTs, high frequency current transformers, on both sides and start to inject the voltage. As soon as we started to inject the voltage, we have seen, let's say, not expected PD pattern from the GIS termination of one phase. We didn't discuss about what is the TF map, but it's quite logical that if you see the three graphs in the bottom, the background noise is flat, the EGBT noise is low and very regular, and then we have in the middle a pure PD pattern with some strange pulses correlated with different phase angles. That was a PD signals. As per the site, let's say, regulation with the cable installer, we asked, okay, why don't we try to increase a little bit the voltage, and we check if the PD pattern becomes more frequent and higher in amplitude, so that we can confirm it's a PD, because higher voltage, higher PD. We increase of 10 kV the voltage when we have seen a higher repetition rate of the pulse, so more PD pulse per second, and an higher amplitude of the PD pulse. So we raise our hands and ask to the RTS guy to shut down the voltage injection because of a PD, because of termination affected by PD. It was possible to prevent the termination fault. The crew has changed the stress cone of the termination, and we have found some burning traces, some evidences of partial discharge on the stress cone. Once the termination was, let's say, put in place again with the new stress cone, the measurement was very clear. If you can compare this pattern with the previous pattern, you can see a very strong difference between these two. Second case studies is more about huge test. This is one of the biggest tests we have performed recently. It was a double circuit of 20 kilometers, and we had totally 12 outdoor termination and 210 joints. So if we make the math, you can see that we had 6 engineers a total number of detection point, it was 200 and 222. And we could, in these cases, having such long cable, you can inject voltage in just one phase. So you have to repeat the same test 6 times in this case. And if we go sequential, so if we move along the cable, it will take for every phase, for every cable, 7 shots, because the number of accessories for each cable was 37. Our idea was, okay, doing the test in a sequential mode will be really hard under many points of view and will be very costly because we have to basically stop the city traffic for 10 days. The solution together with the customer was to prepare the HV circuit to be tested with a simultaneous test. It was a very, let's say, long-term vision by the customer. They provided a small pit where we had access to the PD sensor derivation box, permanent sensor installed in the joints. We had a fiber optic connection box, and there was room enough to install one car battery and one of our temporary PD hubs in these pits. So the idea was we prepare the test, we connect our temporary PD hubs to the PD sensor derivation box, we energize with the car battery, and we connect with the fiber optic. We do this activity for 1 day, we install all the boxes, then we start injecting voltage every phase, and every phase we will have just the HVAC test plus 2 steps at the beginning, so every phase will be tested in, let's say, 2 hours, and all the job will be much easier. In this case, we didn't find any PD, so there is no evidence of PD, but what I wanted to share with you was the real schedule that we had in this project. Here on the right, you will see a little bit messy all the installation made with the car battery, temporary PD hub, and connectors for the PD signals to the temporary PD hub. On this chart, you will see the scheduled activities and the real performed activities. We had actually some delay because of fiber optic issues in 2 portions, but luckily we were able to, let's say, manage it. And in the end, all the 222 accessory test was finished in 5 days and a half. From the PD hub installation to the PD hub removal. And with just 1 day and a half of traffic control required. Especially on this day, we were able to test 4 phases, thanks to architecture of the simultaneous test. We had everything in place. Every cable will take just 2 hours. Another case studies. In this case, even in this case, we had quite, let's say, expert in PD customer that asked to have permanent monitoring systems. So they have the infrastructure with the acquisition boxes all along the cable already prepared, and we were involved in the PD commissioning. Thanks to the sensor position that in this case it was very sensitive, we were able to find a really small PD activity. If you see this pure PD pattern, just to let you understand why it was such a small PD activity, if you see some horizontal white lines, it's not because of a picture problem, but because if you look at the amplitude, we were just next to the minimum ranges detectable by our instruments. So this is the pattern recorded at 106 kV on this joint. We have seen a PD occurring with a 2 millivolt amplitude, and we realized to double check that was a PD up to 132 kV, and we have seen the PD evolution in both amplitude, pattern, and repetition rate. As per the case study number 1, test interruption and joint replacement in this case. After we have replaced the case, we were able to check that everything was perfect. And if you see, thanks to the permanent sensor installed, in this case, the background noise in the middle of the cable is half millivolt. It is a very low level that we have reached. this was the last slide from the presentation, and now I will try to look for some of the questions those have been made. I kindly ask Francesco, that was answering your question directly, if he can maybe send me on the chat of the instrument of the webinar some of the most let's say classical question.
Maybe if it's possible, Lorenzo, that you open the questions part and just check the ones which are not answered. And of course, Francesco can pitch in and suggest which questions to answer.
Okay, sorry, I'm not so familiar yet with this software. Sorry for that.
If you go to the right in questions,
yes,
you can also increase.
Because I'm using the other one. I'm using not the web page, but the app. So.
Or if you want, we can read the questions out for you. That's also okay for the ones which.
Wait. I have some questions. Okay. Now I can see them. First, Francesco asked me. Actually, this is like I expected this kind of question, but is more accurate. Somebody asked maximum length we can check with the TDR. So actually, the TDR is time domain reflectometry is a little bit, let's say, second level webinar, and the maximum length we can detect if we consider end to end of the cable today with our instrument is 3.5 kilometers. But there is another limit of the TDR that is not just due to the waveform length, but also to the attenuation that we see along the cable. That is, let's say, I hope that we will have a second level webinar because there are so many things to discuss about that question. Another question that Francesco is suggesting me, how does alpha work in every condition? So basically, the KIM technology has got some denoising tools. Denoising tools, they are able to remove the noise from the measurement. Once we are doing a measurement, there are two key points. Install the sensors properly, get the signals properly, and then there is data analysis. The alpha basically is like an helper. You open the software of the alpha, it will ask you what we're going to test today. We're going to test a cable. Okay, please tell me what is the cable layout. And there are all the possible, let's say, layouts we have seen in our lives with and the instruction to install the sensor for this specific layout. Then when everything is installed, we can, let's say, launch the acquisition part. First, the unit will check if we have the proper signal from the synchronization and from the PD, and then it will apply different denoising solutions to the data streaming. Basically, it will make the acquisition in a huge number of parameter setting solution, and that will, let's say, give us the chance to have good data. Another question, resonance frequency is always the same. No, a resonance frequency depends on the cable, on the capacitance of what we are, let's say, energizing, and the capacitance depends in the cable case on the cable lengths. So our friends from IVOL, for example, they provide the RTS that they will, once they are connected to the cable, they will evaluate the capacitance and they will find the resonance point of the instrument, of the cable to be energized. So this is something automatic and will change with the cable length and also how many phases we are testing. Shape of embedded sensor and how do we connect to the acquisition box? This is, let's say, very interesting question because embedded sensor, we have some different, let's say, schools different solutions we can provide. I have experience with at least 3 of them, and it's we have, let's say, customized for each of them some signal conditioning devices to work safely and properly with this sensor. It's quite specific depending on the cable manufacturer, and I can tell you that there are mainly 2 different schools, one from Europe and one from the Far East. On the Europe, we use more capacitive sensor, and normally they came out with the connectors as BNC or Fisher connectors. Then it is required to install something between this connector and acquisition unit to maximize the signal to noise ratio and to work safely. Instead, the Far East school is with inductive sensor, so there is no voltage involved, not as much as the capacitive at least. And there are normally 4 sensors for each accessory. And in this case, we can connect directly to the oscilloscope. Let me just check another question. This was about the alpha, TDR. Okay, does this there is a question about if we pick up some 50 Hz signal in the screen of the cable. If we work in substation, it is possible also nearby power lines. Actually, we don't care too much about the voltage in the screen, because what we, let's say, take care is the biggest voltage will be the one from the conductor to the screen to start the PD. The 50 Hz signal in the cable screen can give us a problem to synchronize, but sorry, maybe I'm going out of the question. But we okay. So delta 50 Hz. So our high frequency current transformer won't detect such a low level, low frequency signal. For the 50 Hz noise is not a problem for us. For us, the problem is more on the higher noise. The 50 Hz can be a problem for the synchronization signals. That is necessary to build a pure PD pattern. And since I see that some people is leaving, I will just introduce the last slide where we have our address, my email address, and I have put also a screenshot of the website where you can find the new webinar page. And I guess that if Francesco doesn't have more, I will close here this question and answer. I hope that you enjoyed our presentation. It was my first experience with the webinar, so I hope it was not too much boring for you, and you have received the information that you were looking for. I hope to see you on soon in the next webinar. Do not hesitate to contact me or any other Altanova group person for any requests or any comments. And Andrea, if you want to say something more, I don't know.
Well, I just wanted to thank you for the knowledge and for the attention. This was really, I think, interesting for all of us. And in the future, when we finish with the webinar, please just fill in the survey so that we know what would you like us to talk about. We do have some webinars happening in about 5 to 7 days. It's also about PD and about medium voltage cables, monitoring, testing, etc. So also, please, you can subscribe to that. It was also my pleasure to have you once again, and I hope to talk to you and to hear you soon. Have a nice day, and we will close the webinar now.
Thank you so much. Bye.
Lorenzo, I think you have to close it.
trying to find out where I have to do it. Sorry.
In the sharing part, in the top.
The sharing part.